So this video will talk about introduction to alkane. Well, alkanes are family of organic compound or family of hydrocarbon that are characterized by unique properties. And if you are a student taking a chemistry test, I want you to note all these properties, because these properties are very, very useful in a multiple choice exam system, especially those in Nigeria. So alkanes, like I said, alkanes are family of hydrocarbons or organic compound characterized by the following unique properties. The first one is that they have carbon to carbon single bonds. This means that they are saturated. They have carbon to carbon single bond. That is, they possess only, that is, they possess only sigma covalent bonds. Sigma covalence bond. The next one that we interest you is that the carbons in an alkane are sp3 hybridized. sp3 hybridized. The next thing that also interests you is that an alkanes have a tetrahedral geometry and shape. The next thing that also interests you is that they have a bond angle. Their bond angle has a bond angle of 109.5 degree. Some textbooks call this bond angle perfect tetrahedral. And also, they have a general molecular formula of CnH2n plus 2, where n is an integer from 1 to as many as possible to infinity. And then another that also interests you is that they are also called paraffins. They are also called paraffins. And finally, they are classified into two major groups. They have the aliphatic alkanes. Generally, aliphatic means straight chain alkane or open chain alkane. And we have the alicyclic alkanes. By the way, some textbooks might call these cycloalkanes. They are basically alkanes that their rings are closed. They're not aromatic in nature, but they're just alkanes that have a closed ring. So these are about the important points to note about the properties of an alkane. And by the way, an alkane is an homologous series. And in my previous video I made about the homologous series, I don't know if I said it there, but it's good to notice that members of the same homologous series have the same general molecular formula. And also, it's also important to know that cyclic alkanes or cycloalkanes, their general molecular formula is CnH2n. Please note this, especially those of you that I take a test of multiple choice questions. So general formula of cycloalkanes is CnH2n. So let's talk about the general members of the homologous series of alkanes. That's at least the members that you're supposed to know. And these members usually serve as the parent name of an alkane chain. In another video, I'll do the IUPAC nomenclature of alkanes, and you see how we can apply these general members into the names of those structures. So using the general molecular formula of CnH2n plus 2, and we said n is an integer from 1 to infinity. So when n is equals to 1, the first member that we have, if you put n as 1 here, it will be C1 H2 times 1 plus 2. This will give you C, 2 times 1 is 2, 2 plus 2 is 4. Give you CH4. This is what we call methane. What we call methane as the first member of the alkane family. So in another video of mine, I talked about homologous series, and I said that members of an homologous series, they differ from each other by a CH2 group, meaning that to get the next member of an homologous series, all you need to do is to add CH2 to the previous member. So we want to add a CH2, just like a shortcut for all of us. You want to add a CH2 to this CH4 to get the next member. So C plus C give you 2C. Now H4 plus H2 give you H6. So the next member, we have a molecular formula of C to H6. And C to H6, I want to announce to you, my audience, is ethane. So if you add CH2 to C to H6, you add CH2 to it. Now C2 plus 1C gives you 3C. Now 6 hydrogen plus 2 hydrogen gives you 8 hydrogen. So the next member will be C3H8. And C3H8 represents propane. Propane. The fourth member, if you add CH2 to this, 3 carbon, let me write it so you can see, plus CH2. 3 carbon plus 1 carbon gives you 4 carbons. Now 8 hydrogen plus 2 hydrogen gives you 10 hydrogen. That gives us the next member of C4H10. And this represents butane. Now the fifth member, if you add CH2 to C4H10, you have 4 carbon plus 1 carbon giving you 5 carbon, and 10 hydrogen plus 2 hydrogen gives you 12 hydrogen. So that will give you C5H12, and this is pentane. So I want to give a task to the audiences that the task on writing the molecular formulas of the 6th member to the 20th member. I'll write the names. All I want you to do is in the comment section write the molecular formulas of the members from number 6 to number 20. All you need to do is to add CH2 to the previous member, and feel free to comment in the comment section. So these are the names of the members of the homologous series of alkane from member 6 down to member 20. 6 is called hexane, 7 is called heptane, 8 is called octane, 9 is called nonane, 10 is called decane, 11 ondecane, 12 dodecane, 13 tridecane, 14 tetradecane, 15 pentadecane, 16 hexadecane, 17 heptadecane, 18 octadecane, 19 nonadecane, and 20 ecosane. So my task for you is to write the molecular formulas by adding CH2 to the previous member. So feel free to comment to write this in the comment section and engage. So, and also have an assignment, a note for all of us, that a 50 carbon alkane, that's an alkane that has 50 carbon in its structure, the name is called, just like this somewhere, it's called pentacone. Just write it somewhere. It's called pentacone. So that's about it for this video. The next video will be on the aliphatic nomenclature of aliphatic alkane and alicyclic alkane, or combination of both aliphatic and are the cyclic alkanes. So that's about it. Thank you for your time. Thank you for your patience. Thank you for watching and listening to this video. I remain mastermind of Mastermind Tutorial. Have a good day, everyone.